Okay, welcome to this lecture. Today we are going to discuss Newton's backward interpolation formula. As we know that we have already discussed the Newton's forward interpolation formula on previous term. Through that formula we have seen that how to compute the value of the function in the beginning of the data set. And it is also seen that Newton's forward interpolation formula is also capable of extrapolating the value of the function little bit backward from the beginning value of the function or beginning values of the data set. Therefore, it is clear from this method. This means the Newton's forward interpolation method that it is not going to estimate or it is not going to interpolate the value of the function at the end of the data set, or also it is clear that it is not capable of computing the value of the function at the uh, at the little bit later or little bit forward from the end values of the data set. Similarly, it is also not capable. It is means the Newton's forward interpolation formula is not capable of computing the value of the function at the midpoint or near the midpoint. So now, in view of this, we need to discuss some new method of interpolation, and therefore, in order to overcome this situation of interpolating the values of the function at the end of the data set or little bit forward or little bit later from the end value of the data set, we design and develop a new method that is popularly known as Newton's backward. This is Newton's backward interpolation formula. So this is a method through which we can discuss several such kind of discussions what we raised during the introduction of the backward interpolation formula. So in this way, what we do or what is our purpose of handling this method? The main purpose of handling this method is how to derive the Newton's backward interpolation formula, as well as how to discuss the applications of Newton's backward interpolation formula. So today we are going to discuss this method in two parts. First, the derivation, and the second part is the discussion about the application of this method. So as usual, we assume there is a function. Let y is equal to fx be a function with n plus 1 data set, and this data set is nothing else but the xi, yi. I is ranging from 0 to n. So 0 to n means it has n plus 1 data set. Now we also further assume that phi x be a polynomial. What is this polynomial? This polynomial is going to represent the function. So our polynomial is phi x, a polynomial of degree n, because the data set is number of data set is n plus 1, and therefore it has the degree n less than the number of less than 1 the number of total data set. Let us also begin with the phi xi is equal to yi, because y is what the value of the function. This is being estimated with the help of the phi x, and phi x is what? Phi x is the polynomial. And therefore, since polynomial is going to represent the function y is equal to fx, and therefore this is going to satisfy this equation. Rather, you can say, if you are interested, you can say like this. It is just equivalent, and therefore the value of the y will depend on the value of the phi x. So what is more to discuss here? We have the arguments. One assumption is laid down here, that arguments are equally spaced. These arguments are equally spaced with the interval h. H is what? This is the width of the interval or differencing, such that the xi is nothing but the xi plus ih. Means x1 is x naught plus h, x2 is x naught plus 2h, and x3 is x naught plus 2h, so forth, so on. Let polynomial phi x be written as, we have discussed a lot about this polynomial, that how many types, how many ways this polynomial can be written. We have seen the Newton's shifted power form polynomial, which was used in the Newton's forward interpolation formula. We have seen Newton's popular representation of the polynomial, which was used in the derivation of the forward interpolation formula. Now, in the similar way, we have written this phi x is a naught plus a1. If you remember the forward, Newton's forward interpolation formula, then this only difference with this is that there, if you remember, there was x naught here. In place of xn, there was x naught, means beginning value. Here is the end value of the argument. And a2 is what? X minus x1 into x minus n minus 1. This one. So this is a n minus 1. Last term is x minus x1 into x minus x n minus 1, and x minus x1. This is last but one term. Last term is this an, x minus xn. So forth, so on, x minus x2, x minus x1, and last is x minus x0. And if you only the difference, if you observe the difference here, the only difference is that what we realized between this polynomial and polynomial used in the Newton's forward interpolation formula, that this way of writing is reverse. Here it was x minus x naught, x minus x1, x minus x, so forth, so on. Here was x minus xn. Now here x minus x naught is last. Okay, so this is the fundamental or the basic polynomial on which we are going to have the discussion regarding the derivation. What we are going to discuss further, that let us substitute the value x is equal to xn in A. Similarly, if you remember, here we used to put the value x is equal to x naught. If you remember and reminisce your previous lecture, then you will realize this very point, that here it was x is equal to x naught. Now, in different way, the end value we are substituting here, x is equal to xn in A. This implies what? This implies that everything goes vanished. Everything goes vanished. If you remember here, now xn, x minus xn. So xn is here. So these all terms go vanished. Only a naught remains, and therefore phi xn is equal to a naught and plus 0 plus 0 suppose 1 is a naught, and therefore a naught is equal to yn, because this is the phi xn is equal to yn as per the assumption that it is going to represent the function. So this will compute the value of the function. Further substituting s is equal to x n minus 1. Similarly, we are assuming x is equal to x n minus 2. So for so on up to the last term is beginning term, x is equal to x naught. What happens? We get different values in the same polynomial as we have denoted by a, which in turn gives us a1 is equal to, look at here, interesting, a1 is equal to y1 minus yn minus 1 minus yn, and this denominator is xn minus 1 minus xn, and this is the backward difference, first backward difference yn, and this is the factorial 1h. Similarly, the a2, this is the second backward difference yn factorial 2h square, a3, value of a3, and an. We have computed also in case of the Newton's forward interpolation formula. Now substituting the values of a naught, a1, and an in a. All values are substituted here. All values are substituted here, and then ultimately we get in this way. The only here we have substituted the value of the coefficient a naught, a1, a2, so forth, so on, an. Only remaining things which are as it is, which are same, is this part, and this part. And coefficients have been substituted by its evaluated values. Okay, as usual, in case of the Newton's forward interpolation formula, we had introduced a new variable. I had told you that new variable is introduced with the help of the introduction of the new origin and new scale. So here scale is also changed, that has been made by h, and the origin is also changed, that has become axn. Earlier in the case of the forward interpolation, Newton's forward interpolation formula, this was x minus x naught upon h. So here h is the interval of the difference or the width of arguments, and in this way we have discussed a lot on the introduction of this new variable, and therefore this new variable v x minus x naught is written in this way. This x minus x1 is equal to vh. Similarly, we find x minus x n minus 1, and you look at here, simply we have manipulated this term x minus x1 and plus x n minus x n minus 1 here. Then this is additional term which we have introduced. So this minus xn will be balanced or banished with the help of plus xn, and minus x n minus 1 is this part. So this is what x minus xn, this is a vh by the above definition of the new variable, and this difference is what? Since the difference is a constant, that is denoted by h, so this value is h. So here h is common, and in bracket v plus 1. Similarly, we can get other values x minus x1, this comes out, or this comes to be this way, and x minus x naught is lastly comes b plus n minus 1. Here you just find and observe the difference with the Newton's forward interpolation formula, that there has been minus here, u minus 1, u minus 2. If you remember this derivation, which was also very exciting process of derivation, and therefore here, but you are finding the plus plus b plus 1, b plus 2, b plus 3, so forth, so on. I think up to this stage, everything goes well. And substituting these values of x minus xn, x minus xn minus 1, so forth, so on, up to this, and last one is x minus x naught in where? In b. We easily get that, you look at here, we easily get that phi x is equal to yn, this is the end term. Earlier in case of the Newton's forward interpolation formula, this was y naught, if you remember. Now this has yn, and this is the first difference, first difference, and the factorial 1. So this b n v plus 1 and b plus 2 and v plus n minus 1, the difference is this one, the backward difference. Nth difference is yn and factorial n. And in this way, we have reached this formula. C is known as Newton's backward interpolation formula. So remember this formula. Remember this formula that phi x is equal to yn plus, now v, this is a new variable. First difference v plus 1, then factorial 2, this is the second difference. Similarly, the last is the n, then here is n minus 1. Here is also second difference, so here 1. You just make it rhythmic for putting it in our memory that is committing to our memory. We have to remember this. Unless we put it in our memory, it is not going to be retrieved or recalled at the time of application of this formula. Thus, this is C is known as Newton's backward interpolation formula. What are applications of this formula? This formula has two applications which cannot be fulfilled by the Newton's forward interpolation formula. As we have already discussed this very point, that what was the discussion, that this is not going to interpolate the value of the function at the end of the data set, and it is also not going to discuss, and it is also not going to estimate the value of the function outside the range of the data set. That is the method of extrapolation is also not possible to be applied by the help of this Newton's forward interpolation formula. Therefore, the first application of this is used to interpolate the value of the function y is equal to fx near the end value of y. This is the first application. And the second application is this is also used to extrapolate the value of the function little forward to end value of y. Little forward, you just look at here, you can observe this example. These are the values x, x naught, x1, x2, so forth, so on, xn. Okay, so and y naught, y1, y2, and y1. If we are interested corresponding to this value of the argument, then this process is known as interpolation by the Newton's backward interpolation formula. And if you look at this point, this is the xn and this is the yn. This is the near the end. Similarly, given this now new argument is given here. It is little bit later from xn, little bit forward from xn. Similarly, the y1, for given this value of the x, we need to estimate or compute the value of the function, and this procedure is called as extrapolation. Extrapolate. So here the 1981, 1991, 2001, 2011, and 2012. if we talk about the estimation of the value of the function of 2005, this is the method of interpolation, and it is near the end of the 2011, and this is called the method of interpolation. That is the Newton's backward interpolation will be used here, because it is end value and near the end value, and this range is finished now. This range is finished now. Range of the data set is finished now, over now, and out of the range we are talking about, this is the 2011. This is 2011. Now this is 12. Corresponding to 12, we are going to estimate the value of the function. So it is known as extrapolation. So far, there are two applications of this method. In this way, it is very easy to apply this method, and therefore now you have, if any questions, then we can discuss.